5,000 is borrowed at an annual nominal rate of interest J, convertible monthly. Loan is repaid with payments of 291.23 at the end of each quarter for 5 years. Calculate J. So this is annuity immediate. Payments are happening at the end of each quarter. And in 5 years, there are 20 quarters. And now if you set up the equation of value, 5,000 was the present value, and then 291.23 was the payment, and then 1 minus 1 plus I to the negative n is 20, because it's quarterly payments and there are 20 quarters. So you can clearly see that you cannot solve this for I algebraically. So therefore, we'll have to use the BA2 plus calculator. And now make sure that the calculator is in the end mode, because this is annuity immediate and payments are happening at the end of each quarter. So the way we make sure is we turn on, and then this is, you see this begin button over the PMT. So you do second begin. So right now it shows that it's in the end mode. And if it were not, or if let's say you want to change it to begin mode for an annuity due, what you will do is you would do second and set. And you see it now toggles to begin. And if you do second set again, it's now back to end. So now once we've done that, we can turn it off and on back. Now we know it's the end mode. So before starting calculations, we should clear any memory, and that can be done by second and clear TVM, which is the second function over the FV button. And now in this calculator, everything should be on the right side, the way that's how it is set up. So that's why if we move this present value to the right side, it becomes negative 5,000. That's why we'll enter negative 5,000 for the present value. So the way we do it is we'll first write 5,000. And then this plus minus key will put a minus. And then we will hit the PV key. So present value is negative 5,000. And then the payment is 291.23. So first we will write the 291.23. And then hit the PMT key. And then N is 20. And we will write 20 first. And then hit the N key. And then we want to compute the interest rate. So now the way we have entered the values, it will calculate the quarterly effective rate, because these are quarterly payments. And so the quarterly effective rate can be found by, you'll hit compute and then I per Y. And it's calculating the interest rate in percentage. So the quarterly effective rate is 1.5%, but we know the quarterly effective rate is I4 by 4. And we have to find the nominal annual rate J, because normally we call J as I4 by 4, but in this particular problem, they are forcing us to call J as the nominal rate convertible monthly. And basically J is what we normally call as I12, because that's the nominal rate convertible monthly. So we use our basic equation, 1 plus I12 by 12 power 12 equals 1 plus I4 by 4 power 4. And they're calling I12 as J, as we mentioned. And the I4 by 4 is the quarterly effective rate. And the quarterly effective rate we found to be 1.5% by the calculator. And so that's 0.015. And so from here, we can find, if you first evaluate this expression, and then take the 12th root, that gives you 1 plus J by 12, and then you subtract 1 and multiply by 12. So J comes out to be 0.0597, and that is choice A.